Hello everyone. In this video, I will be discussing regression analysis. In the previous two videos, we learned about correlation analysis, that's a measure of association. Regression analysis also is a measure of association that measures or that examines the relationship between two variables. But the main difference between correlation and regression is that correlation is used when you are looking for an interdependence relationship, but regression is used when you have two variables. One variable is dependent one and another variable is independent, and you are trying to explain your dependent variable using your independent variable. Then we use regression. Or we can say, if we want to find out how much variation in a dependent variable is accounted by independent variable, we use regression. Another difference between correlation and regression is the correlation is used when both the variables are interval or ratio, and regression analysis requirement is the dependent variable has to be continuous, I mean interval or ratio, but independent variable can be continuous or can be categorical. So in regression, we basically estimate this equation. So y equals to alpha plus beta x. Y is the dependent variable and x is an independent variable. Beta is the slope of a regression line that we want to find out, and alpha is the intercept. So when we estimate this regression, we actually is interested about this beta, because this beta will tell you how much significantly this x variable is influencing the y variable. Or this beta will indicate that how much of the variation in y is accounted by x. Look at this example. We have two variables, dealer sales volume and building permits. So x is number of building permits and y is sales volume of dealers. Now, number of building permits, when more number of building permits are issued by city council, dealer is supposed to have larger sales volume. So we expect that there is a relationship between number of building permits and dealer sales volume. So if we put these numbers in a diagram, it will look like this. In the horizontal axis, we have number of building permits, and in the vertical axis, we have dealer sales volume. Now, what is these dot points? Each of these dot points indicate a combination between this number of building permits and the corresponding sales volume. I mean, when the number of building permit is this, what is the sales volume? So each point indicates a combination of number of building permits and sales volume. Now, where does this line come from? This is actually the regression line we draw by estimating that regression equation. And the slope of this regression line is the beta of this regression equation. This beta is the slope of this line. The slope of this line is rise by run. Now, actually, we draw this regression line to indicate a relationship between these two variables. Ideally, this line should capture all of these dot points. However, you can see that our dot points are scattered in such a way we cannot draw any regression line that capture all of these dot points. Okay. However, our objective of running a regression is to draw this regression line that captures all the points with the minimum error. Okay, what's the meaning of this minimum error? Look, what each of these regression line, what each of this point in the regression line indicate. Each of this point in the regression line indicate a combination between our number of building permit and the corresponding sales. However, actual combination might be different. For example, when we have, say, 160 is the number of building permits issued, the corresponding sales volume is here. However, according to our regression line, the corresponding sales volume is here. That means this is the actual combination. However, this is the combination that is indicated by this regression line. Now we draw this regression line in such a way so that this difference is minimum. This difference between actual and the one estimated by our regression line, this difference is minimum. So that this regression line ensures that this difference is minimum, and the regression line captures these dot points most closely. Now, there are different methods we can estimate this regression equation, or we can estimate this regression line. The one that we will be using is called ordinary least square method. Okay, what's the meaning of ordinary least square method, or we call it OLS? Now, as I told you in the previous slide, that the objective of our regression line is to capture all these dot points as closely as possible. And by looking at the dot points, we see that we cannot draw one regression line that fully capture all of these dot points. So when you use ordinary least square regression and OLS method, that allows us to draw this regression line where the squared error will be minimum. Okay, I already mentioned that squared error or error means the difference between the actual combination between the two variables and the one suggested by this line. So that's the characteristics of ordinary least square method, that the squared error will be minimum. Okay, that means ordinary least square method is the method that allows to draw this regression line with a minimum level of error. So this is the OLS criteria. This is error. If we square them, then it will be minimum. For example, this is our actual combination and this is our estimated combination suggested by the regression line. So this error will be minimum. That's a condition of ordinary least square estimation method. So this is our estimated equation. This is beta, and this is our estimated value or suggested value by the regression line. And as I said that we are interested about this beta, so we calculate beta in this way. Although we do not calculate beta using a separate equation, rather if we run this, I'm sorry, if we run this regression equation in Excel, that will automatically generate beta for us. Now, when we run a regression, we also do a f-test to determine that whether our regression model has been able to explain a substantial variation in the dependent variable. Try to understand what is the main objective of a regression, of running a regression. Objective is to explain the variation in the dependent variable by the independent variable. Now the question is how much of the variation we can explain by the model we run. F-test indicates that whether we have been able to substantially explain the variation in the dependent variable. Okay, so if we have an F value and if we have a P value corresponding F value is less than the significance level, we will say that our model is significant. That means we have been able to explain a significant variation in the dependent variable. R square, we already discussed the coefficient of determination. As I already mentioned, that R square will explain, or R square will represent how much variation in Y, that means the dependent variable, is explained by X. Okay, so this is the one of the most important number in the regression result we will look at, because that actually indicate how successful our regression model is. For example, if your R square is 0.6, it indicates that 60% of the variation in the regression model is explained by the independent variable. If R square is 0.9, it indicates that 90% variation in the dependent variable is explained by the independent variable. And you understand that remaining variation comes from some other variables. So this is the end of our discussion on regression estimation. In the next video, we will be interpreting a regression result. Thank you.